Right now, above your head, something extraordinary is happening. A machine the size of a football field, built by the hands of humanity, is slowly, silently falling back to Earth. It's not broken. It's not malfunctioning. It's simply obeying the fundamental laws of physics. For decades, it has circled our world, a beacon of collaboration and discovery. But from the moment it was launched, it was doomed. This is the story of how the International Space Station solved its biggest, most inevitable problem. The International Space Station, or ISS, is the largest and most complex structure ever assembled in space. It's a testament to what we can achieve when we work together, a collaboration between the space agencies of the United States, Russia, Europe, Japan, and Canada. Orbiting Earth every 90 minutes at an altitude of 400 kilometers. It is our laboratory in the sky, our foothold in the cosmos. It's where we learn how the human body adapts to long-duration spaceflight, how materials behave in the absence of gravity, and how we can prepare for the long journey to Mars and beyond. It is, in every sense, a marvel of engineering. But this incredible machine, this city in the stars, was built with a fatal flaw. A deadly weakness that threatened its very existence from day one. You might think that space is empty, a perfect vacuum. But it's not. Even at 400 kilometers up, the wisps of Earth's atmosphere still linger. It's incredibly thin, billions of times less dense than the air we breathe, but it's there. And for an object moving at over 27,000 kilometers per hour, even that thin atmosphere acts like a brake. This constant, invisible friction is known as atmospheric drag, and it constantly steals energy from the ISS. Every second of every day, it slows the station down. And in orbital mechanics, slowing down means falling. This process is called orbital decay. Without intervention, the ISS would spiral lower and lower, eventually entering the thicker parts of the atmosphere where it would heat up, break apart, and burn into a spectacular but tragic streak of light across the sky. This wasn't a possibility. It was a certainty. The engineers who designed the station knew this. They were faced with a terrifying and seemingly impossible question. How do you refuel something that never comes home? There's no gas station in orbit. There's no intergalactic tow truck. You can exactly land a structure that weighs over 400 tons and is the size of an American football field. The challenge was immense. So they didn't try to design a station that could defy gravity forever. That would be impossible. Instead, with incredible foresight, they designed a station that could be rescued. A station that could be saved from its inevitable fall, again and again. The solution is as elegant as it is powerful. It's a carefully choreographed cosmic dance called a reboost. Unmanned cargo spacecraft, like Russia's Progress, Europe's now retired automated transfer vehicle, or a TV, and more recently, commercial vehicles like Northrop Grumman's Cygnus, don't just deliver supplies, they deliver a lifeline. After docking with the station, these spacecraft fire their own engines. Not to move themselves, but to push the entire 400-ton space station. This gentle, sustained thrust ever so slightly increases the station's velocity. It's like giving a giant coasting ship a slow, steady push uphill, just enough to counteract the force pulling it down. This nudge raises the ISS back into a higher, more stable orbit, buying it more time before gravity's pull becomes critical again. This wasn't an afterthought. This capability was woven into the very fabric of the International Space Station from its inception. The station was built with specialized docking ports, intricate fuel plumbing, and sophisticated control software, all designed for this exact purpose. The Zvezda service module, one of the first components launched, has its own engines that can perform reboosts, and other modules were designed to transfer propellant from visiting vehicles. The ISS is not a static object, a monument floating passively in space. It is a living, breathing system. A dynamic outpost that is constantly maintained, adjusted, and kept alive by the vigilant care of controllers on the ground and the astronauts on board. Without this ingenious system of reboosts, the ISS would have deorbited and been destroyed years ago. All the science, all the knowledge, all the inspiration it has provided would have been lost. Our only permanent home in space would be gone. Every future plan for deep space exploration, whether it's a mission to Mars, a base on the Moon, or colonies on other worlds, depends on the lessons we are learning right now, keeping the ISS alive.